Hello, everyone, and welcome to my presentation. I am Francisco Aguirre, a Rust developer working at Parity Technologies, working on the Bridges team, mainly focused on XCM. So today I want to tell you guys the things I've been working on, the things we've been working on, some things that are rolling out, and what we have planned for the future. There we go. So first, a refresher. For those of you who don't know, one of the key promises of Polkadot is interoperability, and one of the aspects that helps provide this is XCM. XCM is a language for communicating intention to consensus systems. So unwrapping this very quickly, it's a language where we write the intentions that we want a parachain or a smart contract to do, and we can execute them either locally or send them to another consensus system, being an overall term that can mean like a parachain, a smart contract, and so on, and they can execute it. So that's the main idea behind it. It's the application layer of your interoperable applications. So let's start with a scenario to know why we did and why we're doing the improvements that we're doing. Let's say you're a team, there's a team in the ecosystem. It's building an app, and they have a parachain, that's why a team's chain, and another chain, and they want to build some functionality that uses somehow the functionality from the other chain. Maybe it wants to do some governance on the other chain, maybe it wants to go in there, make a swap, or whatever it might be. So usually what would happen is the dApp submits an extrinsic. We all know this. It's the external data that comes in. It's the transaction that the user wants to perform. Then the team's chain does some local work. This can be sending some balances or doing anything that it might want to do locally. Then it needs to send an XCM or a cross-consensus message. That's what it stands for, by the way, to the other chain. And then the other chain does some remote work. And usually the dApp would be connected to both chains, and it would check for events to know that the other chain's work was executed correctly, and then it can tell the user, hey, you did whatever you wanted to do. So along the way, there are a lot of fees that need to be taken, fees that get deducted from the funds of the user. So I'm mentioning this. Usually when we interact with blockchains, we don't think too much about fees. We just know every action has some fee associated to it. It's very easy to get. We need to know it. We use it, and that's it. But here there are more fees. Instead of the local, only having the local execution fees, we also have the delivery fees, which is the price to pay for the actual work of getting one message from one place to another. And then we have the remote execution fees that are on the other chain. So XCM provides already a way to set all of these types of fees in the easiest way possible. But there's, right now, or until now, let's say, it was very complicated to estimate both the delivery fees and the remote execution fees. So this was a clear pain point, that it was difficult to know if you were getting this right, which could result in bugs. So what we did, and this is an update that is already available on testnets, so Rococo and West End, and is rolling out to Kusama and Polkadot as we speak. We added some APIs that let you easily estimate all these fees and make for a better user experience. So those two are the XCM Payment API and the Dry Run API. The first one concerns itself with getting the delivery fees or the execution fees or whatnot. And the second one is very versatile and lets you dry run your extrinsic or your XCM itself and get all the results from execution. And these two work together to give you the full information about the flow that the dApp then can use to tell the user, hey, this will succeed if you run it, and this will be the fees, and everything will work smoothly. So how would it work? So to integrate this on your dApp, you would first, instead of having the user just submit their extrinsic, you would first dry run it to see if it's successful or not. So this dry running is not just something you do on tests. This is something that will be live on your chain. And you can in your dApp, do the dry run, tell the user if it will succeed or not, so you can take the decisions accordingly. And then if it's successful, you can get the remote XCM. So the XCM that would result of executing that extrinsic to be sent across to the other chain. With that information, you can get the delivery fees, and you can dry run that message on the other chain and also get a success value. So now your dApp can tell the user if this will succeed or if it will error at any point along the way. Here we have only 2 chains, but if we had a lot more hops, you on your dApp could be able to show a nice error message telling, hey, it will fail on this hop for this particular reason. And then you can get the remote execution fees to make sure everything is done correctly. I know these are a lot of steps. It's what you get when you want to do like cross-chain interactions, but this can be all abstracted away on the dApp. This is just the flow dApp will take. But the user doesn't need to know that all these hops are taking place or anything. It's just a tool to make the dApps able to give a better user experience. OK, so all those things that we talked about, this is something that's already coming and doesn't need a new version of the language. When it comes out, which will be soon, there's already a PR for the runtimes. You will be able to use it. But then XCM, there are many other things we can do to make the developer and user experience better. The thing is, XCM is a versioned language, and we're kind of limited by what we can do on one particular version. So on the next version, we have more flexibility of what we can add and how we can change the language. So on the next version of the language, which is V5, we're currently on V4. There's also, if you see chains using V3, that's also acceptable. Every version is backwards compatible, so we don't break anything. In the next version, right now, there will be a new mechanism to pay for fees. Right now, you usually do this withdraw asset instruction. This is part of the language. And then you buy execution, which was meant to reflect that we only ever have execution fees. And then you continue with the rest of your program. Now we will have a new mechanism that basically integrates the delivery fees that weren't taken into consideration before. And there have been a lot of issues around them before. So it's just changing one instruction to the next one that makes things seamless to the user. I mean, aside from this change, everything will start to work better. There will be less bugs, and so on. In V5 also, we're removing this instruction, which you don't need to be familiar with it, of course. It's just one quirk of the language. But basically, this set fees mode instruction allowed to sidestep this fee mechanism and produced very unpredictable results, like not allowing the user to specify how much they are willing to pay for delivery fees, for example. So the user could be surprised by how much it cost, or it also led to some bugs. So we're just removing it, making the language more simpler, easier to reason about, and more stable. OK, those are 2 things that are coming to the next version, the next revision of the language. We talked about a previous scenario. Let's talk about a new scenario, which is a very common thing on the Polkadot ecosystem, which are cross-chain transfers. Most of you will probably be familiar that when you're dealing with multiple chains, you want some assets from one chain to go to another one. And in the Polkadot ecosystem and built into XCM, we have two ways of doing these cross-chain transfers. We have the teleports, which you might have heard of before. And we also have another method which is more sophisticated, which is called the reserve asset transfer. We actually use both of these regularly on the Polkadot ecosystem. And this is basically how they work. Let's say chain A wants to send some funds, maybe some local native tokens, to chain B. The way they would do it normally is going through the asset hub, which is a system parachain that we have on Polkadot that is based, it's thought to be the base or the hub for all the assets in the ecosystem. And you usually do this transfer, but chain A doesn't need to know or care too much about the fact that it's going through asset hub. Now, we can pay fees in different assets on Polkadot. This is live right now. Because we have some small liquidity pools on Asset Hub, you could execute, submit an extrinsic or execute an XCM or do whatever you want on Asset Hub. And you can choose to pay for fees any asset that has a pool with DOT or with KSM for Kusama, for example, or for whatever for the testnets. So in this case, they would be USDT, USDC, maybe ETH as well, because we have the bridge now. There was an issue with the delivery fees that meant that you would do this cross-chain transfer, but then, for example, sending USDT from chain A to chain B, but then it would fail on the middleman on Asset Hub because you didn't have any DOT. So that is being, there's already a fix. It will be fixed on the short term. And on the long term in V5, where we can do more things, we will patch it up and make sure that not only you can do things on other, not only can you pay fees on other assets locally, you can also transfer any asset you want. If you know all the hops in the middle, you can just do a USDT transfer without ever needing to know about DOT, for example. Or if anyone accepts DOT, you can just do a DOT transfer without all the local fee, assets. So for example, you can look at the Asset Hub functionality and integrate that into your own chain to be able to, for example, allow your users to pay your fees with DOT or with stablecoins or with whatever you want. Then, also in V5, we want to improve the trapped assets situation, which some of you might have heard about. So right now, if there's an error at any point in the transfer, the assets will get trapped in the chain that they are in right now. Because if there's an error, there's no way we can roll back if rolling back means going back to the other chain, because that's a lot of work. What if that fails again? And so we need to trap them locally. With this issue that we have, things would usually get trapped on Asset Hub. This, the way things are done now, requires governance in general from the chain that sent the message to claim the trapped assets for the user and give them to him back. This is a bad user experience, and we want to improve it. And so we will add a new instruction, which is not something you would have to know about. It just allows transfers to let the user themselves go and claim their own assets, and then they can do whatever they want with it. They could deposit them to a local account on Asset Hub, or they could teleport them back or reserve asset transfer them back. So that makes sure that with the first things that we discussed, we try to have the least number of bugs as possible. And with this one, even if we do have bugs, we try to make the resolution of those bugs as easy as possible. Then here's a nice QR code. There's a repository that you should check out. It's called the Polkadot Ecosystem Tests. It's ecosystem initiative, I think led by Akala, because it's now on the ORML organization. And it's basically a repository of end-to-end tests for all the chains that want to be there. If you have a parachain and you're not there yet, then you should probably go check it out. They do tests with Chopsticks, which is this tool for end-to-end testing. And this allows us to have regression tests with live data. So usually we have a lot of tests, but they're usually with mocked data. And we really to be as stable as ever and to make sure that nothing breaks whenever we make a new upgrade. It's a good idea to have regression tests with live data, which we can achieve if everyone starts, as long as everyone starts putting their tests in here. This is just one initiative. There might be more, but it's a good one to make sure the whole ecosystem is stable and tested and works. So regarding the transfers and V5, if you have been in this ecosystem for a while and tried to do cross-chain transfers, you know that the basic building blocks for them force you to put all your assets into one of two buckets, which we mentioned before, either a teleport or a reserve asset transfer. This is kind of artificial, and we've built utilities that let you transfer whatever you want. Maybe you have to reserve asset transfer some tokens, teleport others. But now we're adding into the language an instruction that lets you mix and match these two types of transfers. So you can do whatever you want, transferring NFTs, DOT, native tokens, whatever you want. Why is this relevant? If you have ever tried to execute an arbitrary XCM on a chain, you might have gotten an error because we were filtering those out. We were not allowing users to actually write raw XCM programs. We were just allowing them to use our extrinsics that do these things on the background. Well, not anymore, because we are allowing now arbitrary XCM execution after going back and forth and checking that everything is safe. We are adding it to the relay chain, to all the system parachains. So now, if you want to go into the docs and see what you can do and read and build raw XCMs, you can go ahead and execute them locally on any chain, at least system parachains or the relay. Then another thing that you might be thinking if you have tried this before is we used to have a filter telling you what functionality from a chain you could access when you send a message. Now we're removing that filter, which means if I send a message to another chain and that chain accepts it, then you have access to all the functionality on that chain. So whether it be governance or staking or whatever, you have access to all the functionality on all of the chains you're connected to. Next, there's the XCM cookbook, which is part of the new XCM documentation, which is a good place to have a lot of examples of how you can do things, like configuring your parachain for XCM, which everyone knows it's kind of a bummer to have to do. And then also what types of messages you might want to write. Like what if I want to write a raw message to do a transfer instead of relying on a helper function? Then you can, there will be examples here. So right now we have how to use DOT on your parachain. For example, if you want to launch a parachain and you don't really have any like tokenomics planned, then just don't have a token. You can always use the DOT token. You can receive it from the relay chain and then use it, doesn't matter. If you do want to have a local, like a native token, then have it, but still useful to use the DOT token as well. Then how to use other parachain tokens. Maybe you want to have a Glimmer or some other. And then how to register your asset on Asset Hub, which when you register your own, you have a parachain and you register your native token on Asset Hub, you open up your ecosystem to the rest, to all of the chains connected to Asset Hub, which are most of them. And then many more are thought and coming. And if you want to contribute or have any thing you want to do or want to have an example about, then do open an issue. This is on the Polkadot SDK repo. Yeah. And that was pretty much it. So thank you, and we can move to questions.
Any question?
Hi, Francisco. Thank you for the presentation. I had a question regarding the APIs you mentioned for the fees. The XCM payment fee and the dry run API, sorry. Yeah.
Yep.
Could I use them actually for monitoring the transaction or just for the fees? I mean, because before knowing about these APIs, I would, for monitoring, I would listen to the events in the destination chain, for example,
Yep.
to see if my transaction arrives. But can I actually use this API to know the exact state of my transaction without having to listen to the events?
Yeah, so this is not for like things that are running right now. So if you already submitted a transaction, you're not getting information on the actual state of the transaction by dry running it. It's like a separate stage that you do beforehand. But it's a good question. That one is a good question because yeah, the XCM payment API mainly deals with fees, like some things that you couldn't do before, like how much does this XCM weigh? Now you can ask the chain and it can tell you, for example. But this dry run API is very flexible. So you can do what you mentioned, but just before the transaction, you can dry run it, and it will give you whether or not it was successful, which gives you a good idea that the actual extrinsic will be successful. And this one also returns the events. So you can dry run it, get the events, and then, I don't know, even with that, you can even know like what events to listen for. But now the regular way of listening to events to know when something is finished is still there and is still the case. But this gives you a very good story of making sure that it works before doing it.
Okay, thank you.
There you go.
We have time for one more question. Let me check. I suppose we have one more question.
Okay.
Wanted to ask about, especially now that arbitrary executions are available to people, and the bridge is approaching to a more stable state where transactions can be executed. Is there something on the roadmap that includes unique universal locations for things that are on both sides of the bridge? I mean, you now have converters for sovereign accounts for locations that are within a consensus, but not across consensus. So it'd be a nice idea for XCMV5, I guess.
Yeah, I mean, we have a very flexible way of converting these XCM locations, which is the way XCM represents like accounts and palettes and so on. We have a very flexible way of converting those into accounts, so sovereign accounts that represent the location. They could definitely be added. I mean, we have ways to reference other ecosystems like Ethereum and so on, and these are being used by the bridges. So I don't see any reason why they couldn't be used. What's more, I think they might be used in some bridge. I mean, to hold, like having a sovereign account of Ethereum, for example, it might be used. I don't know. But it can certainly be done, and if we want like a standardized way of doing it, can definitely be proposed. Yep.
We have time for one question.
Hi, Francisco. You mentioned that new XCMV5 stuff is available on Rococo and West End. Is it also available on Paseo?
Okay, so the new V5 stuff is not available on testnets. This dry run API and XCM payment API is. Yeah, it's not on Paseo, no, but I could integrate it. I mean, anyone that works in Paseo, hit me up so that I know how to do it. But yeah, I should integrate it there. And one extra comment about the dry run API and so on. They will be integrated into the relay chain and all the system parachains. But we added helper functions so that if you want to integrate it on your chain, it's like copy and paste 10 lines of code and you're done. So yeah.
Thank you.